You know that feeling when you're looking at data and you see two things that seem to move together, and you just wonder, is one really causing the other? Well, today, we're going to move past just seeing those connections. We're going deep to find the real why. It's time to learn how to think like a data detective. Yeah, this is the big one, isn't it? You see it everywhere. A new marketing campaign launches and sales go up. People who drink coffee live longer. But is that the whole story? Is it really a straight line from A to B? Or is there something else, something hidden, going on in the background? And let's be clear, getting this wrong has huge consequences. This isn't just some dusty academic debate. When we mistake a simple association for true causation, we end up building business strategies on shaky ground or creating policies that just don't work. It's probably one of the biggest, most common traps in all of data analysis. So, to get to that real why, we've got to start by asking the right kind of questions. It turns out there are different levels to this stuff. We're about to climb the ladder from just describing what's happening to asking those powerful what-if questions. Okay, check this out. Most of the time, data analysis lives on the first two rungs of this ladder. Descriptive questions like, what are our sales numbers? Or predictive ones like, can we forecast next quarter's sales? And those are useful. But the real power, the game changer, is on that top rung, the causal question. What would happen to our sales if we offered a discount? Answering that takes a whole different set of tools. So, to ask a really good causal question, you need three key ingredients. First, you need the intervention, the thing you're changing. We'll just call that A. Second, you need the outcome, the thing you're measuring to see the effect. That's our Y. And finally, who are we talking about? That's your target population. You absolutely have to get these three things crystal clear from the get-go. All right, so we know what kind of question to ask, but how do we actually answer it without getting totally lost? Well, any good detective needs a map, right? A way to sketch out the scene of the crime before you start looking for clues. And that map, our number one detective tool, is called a Directed Acyclical Graph, or for short, a DAG. Now, Directed Acyclic Graph sounds super intimidating, I know, but honestly, it's just a sketch. It's a blueprint of how you think the world works. Every circle, or node, is just a variable, like marketing spend or sales, and every arrow simply means causes. That's it. It's an incredibly simple way to put all your beliefs and assumptions down on paper before you even peek at the data. So why bother drawing this little map? Because it does some incredibly heavy lifting for us. It forces our hidden assumptions out into the open. It shines a spotlight on the potential traps, the biases that could trip us up. And best of all, it gives us a clear roadmap for our analysis, showing us exactly what we need to measure and control for to find that true causal effect. Okay, every good mystery has its usual suspects, right? The character is designed to throw the detective off the trail. In our causal detective story, there are a couple of major culprits we absolutely have to be on the lookout for. First up, we have the classic villain, the confounder. A confounder is some third factor that influences both the thing we're changing and the outcome we're measuring. It creates this sneaky, non-causal link between them. Think of it like a hidden backdoor that lets correlations sneak in and pretend to be causation. It's the master of disguise. And then there's the other one, the collider. And oh man, this one is a real mind bender. It's super counterintuitive. A collider isn't a common cause, it's a common effect. It's a variable where two causal arrows smash into it. For example, maybe both being a brilliant scientist and being a great communicator help you get a prestigious science prize. In that case, that prize is a collider. Now here's where it gets really weird. By default, a collider actually blocks any association between the things that cause it. It acts like a locked gate. Which sounds pretty good, right? A closed path seems safe. So if the gate is already locked, where's the danger? Here it is. The trap is that we are the ones who unlock the gate. The moment we decide to control for or adjust for that collider, like if we only look to the people who won the prize, bam, we accidentally create a fake, weird statistical connection that wasn't there before. It's the complete opposite of a confounder. So the rule is simple. Always adjust for your confounders, but never ever adjust for a collider. So, we've met the bad guys, we know about the confounder's backdoor and the collider's trap. So what do? How do we neutralize these threats and finally isolate that true causal relationship we're hunting for? This is where our DAG becomes our superpower.
There's a formal name for the solution. It's called the backdoor criterion, but you can just think of it as a simple two-step recipe. Step 1. Use your DAG to find every single non-causal backdoor path. Step 2. Pick a set of variables you can measure that will block all of those paths. That's it. That's how we clear the way to see the truth.
Let's just visualize the problem. Right now, this backdoor path through the confounder is wide open. It's like a leaky pipe contaminating our clean water supply. The effect we think we're measuring is really just a messy, biased mix of the real causal link and all this other junk flowing through that open backdoor.
But now, look what happens. By accounting for that confounder in our analysis, by conditioning on it, we slam that backdoor shut. The leak is plugged, the contamination is gone. And what's left? The only path still open is the pure, direct, causal one we were looking for all along. It's so satisfying to see.
So let's zoom out for a second. What's the really big takeaway here? This whole process is a fundamental shift in how we think about data. We're moving from being passive observers who just spot patterns to being active architects who map out the very systems that create those patterns in the first place. At the end of the day, it all comes down to this: thinking more clearly before you ever run a single line of code. The statistics, the fancy models, they're just tools. The real work, the real detective work, is in sketching out that causal story. A DAG doesn't magically give you the answer, but it's the compass that will always point you toward it. It's the map you need to navigate the tricky world of cause and effect.